we were like, how do we build more of a practitioner community inside government for tech and data workers? You know, we kind of looking at what was happening in other cities around the country and felt we were a little isolated. So we bought donuts, and we're still doing it. So thanks for coming out. This is Lacey, the Los Angeles Clean Tech Incubator's Lacretz Innovation Campus. The building's owned by DWP. Lacey is a nonprofit that operates this half of the building as kind of a co-working and office space. The other half has some DWP offices, and there's laboratories and classrooms and a clean tech incubator. They have lots of cool events here. Come back. There's many other reasons to come back to this space, and they've been sponsoring us for a long time. Do these slides change? How do we do that? Anthony, where are the slides? Can I just use the arrow? Nope. Cool. Anthony has a fancy new browser called Arc. He will tell you all about it if you talk to him later. Cool. So let's see. Lacey and then Metro is our sponsor this year. Thanks, Metro, for helping us buy donuts and supporting live streaming. These are some tech jobs we want to shout out that are happening open right now in the transit space. Here are some of our favorite jobs boards. These will go out. They're usually in our emails too. And anybody's welcome. I'm always happy to help folks sort of figure out what government agency is a good fit for them. If you're looking for a career change, government is a great option. We have one upcoming event shout out, and that's just Cyclovia. We do not reimburse for parking for anybody, but we would love to tell you that LADOT runs a free bus downtown, several of them actually, but the Dash A serves this building in particular. All right, I've gotten really excited over parking in the last year in particular, joining the Parking Reform Network and reading Paved Paradise. It's a book I strongly recommend if you have any interest at all in the topic, or even if you don't. So I was really excited today to bring out Raynell Cooper from SFMTA, and I'll let him get more into his background and talk about parking.
Great, thank you. We'll do a little laptop switch here. Okay. Thanks. Is that all set up? All right. This will hopefully start booting up soon. My name is Raynell Cooper. I manage residential parking policy at SFMTA, which is the transportation agency in the city and county of San Francisco. Thank you to Vicky and Compiler and the Data and Donuts team. It's really exciting to be able to talk about this kind of, I like to joke that residential parking is kind of a backwater of a backwater. I think for a very long time, up until very recently, parking was very much an afterthought in transportation planning, and that's really beginning to change, which is very exciting. But residential parking, I think, still needs a little bit of love. So hopefully we can give you that. A little bit about myself. We'll start with the boring facts. I studied geography and GIS in undergrad at the George Washington University, and then studied urban planning in grad school. One of those transportation planners that always wanted to be a transportation planner. So very lucky to be doing what I'm doing. Been at the agency since 2018, and I manage residential parking policy, which includes our permit program, which if you don't know anything about it, now you will very soon. Follow up with some fun facts. Broadcasted basketball for my college radio station. I'm trying to get good at Scrabble. I've been going to a Scrabble club. It's very intense, difficult. And How You Remind Me by Nickelback is my karaoke song. It's a great choice if you're in need for a karaoke song. Recommend it. So what we're going to talk about, we're going to start with the case for caring about residential parking, this sort of underloved, underappreciated corner of transportation planning. Talk about how San Francisco, how we approach the residential curb. We'll get really into parking occupancy data. There's so many different types of data that we look at, and I felt like if I could probably go on, probably do a whole semester about each little metric. So I was like, let's pick one and focus in on that and talk about some of the exciting things in the future of the curb. So very brief history of curb management. There's a lot going on. The first parking meter, I think, can be seen as maybe the birth of curb management, 1935. Some department store owners in Oklahoma City got together and said, you know, we need to create some turnover on the curb. So they started putting out the parking meters and kind of went from there. A big turning point in the work that any parking planner does is The High Cost of Free Parking, which is a book by Donald Shoup. He's a UCLA urban planning professor. And really drives home the point about how we as cities and as governments have been mismanaging parking, and we've been inducing other property owners to mismanage parking, build too much parking, not charge enough for it. And then SF Park, another kind of important milestone in the history of curb management. It was this federal project in San Francisco to create demand responsive parking pricing, which is now now seeing a lot more pickup in a lot of other parts of the country. And it's important to note with curb management, I think a lot of the work that's done now by parking planners or curb management professionals at the local government level, that was oftentimes in the police departments and traffic engineering and other aspects. So now we're kind of coming into our own as a fully fledged field, which is very exciting. And I think right now we are very much in a golden age of curb management. We've got so many tools, a lot of great tools, a lot of great conferences, a lot of great things going on both on the government side and on the tech side, private sector side. Things like camera-based enforcement. We've got the parklets, which have been a big change since the pandemic. All of this really interesting stuff with loading payment and being able to actually charge for the curb touches in our intense curbs. And all sorts of other fun stuff. And this has all been really exciting. But I do think that a lot of this is really just focused, much of what's been going on in this space has really been focused on these intense downtown curbs. And in San Francisco, all of the sort of stuff that you see here really can only apply to about 10% of the curb. And it's like the joke about, not really joke, but I guess urban legend about how we're only using 10% of our brain at any time. And we could do all of this to unlock all of that. Apparently not true. We're using a lot of our brain, but for cities and parking, we're only using 10% of our curb. And I think there's actual ways to unlock it. So why has residential parking kind of fallen by the wayside and not getting enough attention compared to all these other parts of the curb? One is we're a very undisrupted space. I think when Uber and DoorDash and all of these other changes came to the curb in the last 10 or 15 years, that really spurred cities to change. It also really spurred the private sector to start looking into things a little bit more. There's also less of a business case. Generally, cities are not really charging much for parking. We'll get into that a little bit on the residential side. So there's less momentum there. It's also, there's a massive scale of this. There's in San Francisco, we've got a little bit meters, and in a smaller city, you can really focus in on your 3 or 4 or 5 blocks that are really important. But for residential curb, that's in San Francisco, that's hundreds of thousands of parking spaces, and in LA, that's even more. It's a lot to wrap your head around, and it's a lot to be able to do with kind of the precision that you'd like. Lots of political difficulties. I think that working with the public, even when you have all the right data, you think you have all the right answers. With parking, it's all very personal, very emotional. The public will often say they know better, and until we get the data to the point that it needs to be, they may be right, honestly, and that's something we'll get into a little bit as well. I have this picture of my supervisor, Hank Wilson, there at a public meeting in San Francisco. He was once compared, I believe it was to Ataturk at a meeting. Just you get a lot of vitriol when you're coming into neighborhoods and talking about residential parking. And then I've been sort of shopping around the concept of this parking nihilism, and I think that's something that affects, especially in San Francisco. I think even if you can show that there's a real serious problem, I think in a lot of neighborhoods, residents are just used to it and are just kind of going along with it and kind of accepted that it's going to be bad. And I think with the tools that we have, we can fix things. We can make things better. But it's just about getting the public to accept that. So why should we care? Why should we be talking about residential parking? And I think in California especially, we're in a place right now where we are seeing a lot of residential growth. These cities have been more or less stuck in amber, a lot of these cities, for the last 50 years, where there has been developments and been in places like the Arts District where we're not near any residential neighborhoods. But that's starting to change with various zoning changes, both in terms of ADUs within the neighborhoods and then upzoning along commercial corridors and transit corridors next to neighborhoods. The pressure on the curb is going to continue to mount. And oftentimes it'll lead to things like people parking on curbs. It'll lead to just really intense parking situations that make things difficult for residents and visitors to neighborhoods to make that work. So I'll talk about our main tool for dealing with residential parking, which is a residential parking permit program. This is a very general definition, but it's basically it's a system of parking regulation that gives some set of parking privilege to some subset of drivers, usually residents in this situation. And in San Francisco, we have a residential parking permit program founded in 1976, which is when a lot of residential parking permit programs were started. This is part of a movement to clean up the streets, clean up congestion, and bring life and vitality back to residential neighborhoods. The first RPP areas were near downtown as the financial district was moving north with the construction of the Transamerica Pyramid, as well as near BART stations. And right now we have 32 RPP areas covering about 75 or 80,000 parking spaces. We'll get into why that's a rough number in a little bit. We sell about 60,000 annual permits plus also guest and visitor permits. And the important thing to know about our program is that it's a resident-driven program, and that's at its core, and that's how virtually all RPP programs work. We're not at this point in the business of going into neighborhoods and telling them what they need and telling them what they want. We're more facilitating this process for the residents. And the advantage there is that it really is a self-determinate process for the neighborhoods. The disadvantage is that it oftentimes makes it harder for us to fix some of the problems that we've been starting to identify with the way we regulate parking. Lots of cities have RPP. We have some in LA, lots of other cities in Southern California, almost all of the big cities in the US except New York City. This slide's actually adapted from a slide I gave to one of the community boards in Manhattan because of congestion pricing. Whenever that comes, there's definitely been some concern. And residential parking permits also big in Europe. But here's the issue with most RPP programs, and you can see here in LA, a permit, annual permit is $34, and that does not reflect the cost, either the cost of enforcement and the cost of actually kind of keeping up the system, and it also does not reflect whatever the market rate would be for those permits. Most cities, sorry about that, most cities are permits are either cheap or free in some situations. They're not built for reducing the number of residents who own cars. They're really just built to keep people out. And they're oftentimes money losers for cities. In San Francisco, we do the math and we hit exactly 100% of cost recovery, but most cities are losing money on the residential parking permit programs. So here's an example in San Francisco of apartment building. If you parked on, sorry, let me mute this real quick. Let me figure out how to do that. Nope, I'll just roll through. The parking permit system is, so in this apartment building, if you wanted to pay to park in that apartment building, it's about $3,600 to $5,400 a year. But that car on the street, they're paying $170 a year. And being in a garage, definitely some advantages there. They're not equal goods, but that kind of shows the disparity. So the way we're generally thinking about residential parking reform as we're going into a more long-range planning process is to think of it less as an amenity for vehicle owners and more as a regulation to advance our agency's goals, like our climate action strategy, our transit first policy, our Vision Zero goals, and our equity goals. And there's a lot of ways we could do that with policy that we aren't doing right now or aren't doing at a large enough scale. The biggest thing that I'm working on in my day-to-day right now is pay or permit parking. So generally our RPP program, it's 2-hour parking for visitors and then, but free parking for visitors, and the permit holders can park for as long as they'd like. In pay or permit zones, visitors pay instead of having that 2-hour time limit. We're also studying charging more for permits in high demand areas, and the proactive expansion and rationalization of our RPP system is part of this as well. Sorry, I'm going to see if I can mute Teams from my phone. There we go. All right. So one of our big projects recently was in Hayes Valley, RPP area HV, and all of these purple blocks are our new pay or permit blocks. And right now we're in the process of studying that and creating an evaluation, and that's been a big driver for me for a lot of these questions and discussions, and in terms of how we deal with data. So there's a whole bunch of metrics that we're looking at when we're talking about residential parking, especially when you fold in pay or permit. But parking occupancy I think, is the biggest one. People want to know, are there spaces on the street available? There's all these other metrics: permit percentage, parking turnover, permit density. These all are important, and these are all, especially as we're looking to charging more for parking. These are all the things that we'll be looking at, but parking occupancy is the one that I want to kind of take a deep dive into today. So I was asked to present our tech stack, and I know some of these talks are from folks in big tech startup world with all sorts of bespoke little tools. We are, I think, relatively straightforward and low tech. In terms of the collection of our on-street data, the biggest is either ourselves or working with consultants to go out and collecting, and subcontractors to go out and collect data. We also, thankfully now, through tools we'll talk about in a little bit, are able to get data from our parking control officers out on the street. We also use, for the permit data, we have our own permit software through Business Objects, and then Genetech up in Montreal help us with some of that enforcement data. Analysis, ArcGIS. I use the ArcGIS Pro logo, but I still use ArcMap. I know it's going away soon, but Dixon Data Suite, which we'll talk about in a little bit from Dixon Resources, and then I'm just Excel. The Dixon Data Suite also uses Power BI. And the presentation is a huge part of this as well, and I think in a good planning grad program, hopefully, if you go to one of those, you can get to use Illustrator a little bit, because I think that's been a game changer for us as well. I know it sounds basic, but being able to put that finishing touches on maps is really helpful. So parking occupancy, real simple number. It's real easy. It's just the number of vehicles divided by the number of spaces, and that gets you your parking occupancy. Pretty straightforward. So we're going to just try to find the parking occupancy here. All right, we've got a little parking lot area. We're just going to assume that it cuts off on the right side, and so we've got to find the number of vehicles. We've got 1, 2, 3, 4, 5, and then we've got 3 more down there. So you got 8. You count the spaces as well. There's these nice little white lines, right? 1, 2, 3, 4, 5, 6, 7 top, and then 7 more. So you get 8 out of 14, 57%. Now that's easy. That's straightforward. Let's look at another one. All right, we've got all these different vehicles on a residential street. So on the south side, the bottom of the street, we've got these, looks like 6 vehicles, and then the top side we have 4 cars, but oh, we have the motorcycle. How do we count? Do we count the motorcycle? Do we count that as a car or not? And what about that car that's parked in front of a driveway? It's sort of technically legal for them to be parked there, but if they live in that house, if they don't live in that house, it's not legal to be parked there. It's also not really a space, right? Because only certain vehicles can park there. So do we count that? But if that vehicle couldn't park there, they'd probably be parked somewhere else on the curb. So do you count that? And then what about this car on right here, where it's just this one car here? But maybe this is 2 spaces. We don't have those nice little lines going on there. And then what about this temporary no parking? This is probably affecting how people are using the curb. But if we come back in 2 weeks and try to compare between the 2 data sets, that sign might be gone. Do we change the supply number because of the sign? Or do we keep the supply consistent and just kind of take in the sign as part of what's going on? And then we have this car parked at the red curb. Do we count that space? Do we not? And we're able to come up with some rules for that and some consistency, and I think coming up with that consistency is really good, but making sure that you have on the data collection side, you're able to be consistent and then understand how these different things affect how you're reporting out the data can be really important. Don't really know what the parking occupancy is here unless you kind of set these rules and set these standards. It seems so simple, but then you start asking these questions. What is a vehicle? What do you do about double parking? What is a space when you don't have the marked spaces? Is it, we've got some pretty small cars out there. Do you do there's some cars that are maybe 12 feet long. Do you just use 12 feet, 14 feet, 16 feet? What about driveways? People parking in front of their driveways. What do you do about these construction signs? And then what is the scale? If somebody lives on this block, maybe they care about the block, but in a place like San Francisco, you're not always parking on your block. You're parking around the corner, you're parking a few blocks away. So what do you care about when you think about parking occupancy? Do you care about your block? Do you care about your block face, your neighborhood? How often do you need to collect this data? This is just, that snapshot was just one moment in time. Do you need more moments to average out? What's the ideal occupancy? What is the number that we're even looking for? What are we trying to reach? And does this number even mean anything to people? If I went to a meeting and said the parking occupancy is 80%, what does that mean to their daily life? How does that interact with the way they talk about or think about parking? All of these questions are ones that I've been working through for my entire time at SFMTA, but I think in this last few months, conveniently, when I was asked to do this presentation, I was thinking about, even though parking occupancy is so key to what we do and what we work on, there's a lot of questions around how to do it consistently and then how to talk about it as well. So we're going to talk a little bit about data collection, and I think there's this paradigm in data of garbage in, garbage out, and I think that never was quite garbage in. I think it's a little bit more of like a goodwill donation center in, where we've got a lot of stuff. Some of it's good, some of it's not. Got to clean it up, got to organize it, and it's the goodwill out, basically. We've got a lot of pieces, a lot of things that kind of work. It needs a little work to kind of put it into a working space, and coming in, it can be a little bit messy, but we can make it work. The supply side, how we deal with that, is really difficult, and this is something that if you're able to keep things consistent, it works. But if you're trying to mix data sets and mix time periods, it can be really difficult. So we have this parking census. We did finished up in 2014. Much of the data is collected earlier, and it's helpful. There was everyone collecting data was well trained, but with the parking census, you had this issue of, first of all, we don't have the data at the block face level, which is really important. And then also, it wasn't even exactly accurate. I found the press release when we finished the parking census, and it says we have approximately 275,500 spaces. When they release the census, they don't say approximately how many people live in the U.S. They say exactly how many people live in the U.S. We also have our parking regulations shapefile. That's where our regulations are kept, and it is. It's not a very high-tech system. Whenever we change the regulations, I go into ArcMap and draw a little line next to the curb and put in all the information. So there's definitely some issues over the course of the decades that we've been regulating parking. Things fall through the cracks. We've been working with Dixon Resources, which we'll talk about, and they've been doing helping us out with inventorying remotely. So being able to have a set of procedures to be able to look at a block using Google Street View and other resources to figure out how many spaces are on a block. And that's been super helpful as well to help kind of expand what we're looking at. And then there's also, when we go out and collect data, there's inventories taken as part of the manual data collection. So when somebody goes out and collects data, this gets inputted into sort of an Excel sheet that looks like this. I've covered up the license plates, but then they put down all the cars and what type of permits and placards and scooters and things like that. And the advantage here is, you have the exact time, and you can work with the consultant, or if you're doing it yourself, schedule that out really well, which is super helpful. But you also have to make sure, like I didn't, as I'm sure Thomas did a great job, but I didn't get a chance to talk to Thomas and make sure to emphasize looking for this and looking for that, and keeping that up, and making sure that was all consistent. But we've been blessed with the Dixon Data Suite, and there's some folks from Dixon here. And this is it's a suite of software that takes in data from our parking control officers. So in the last, around 2022, we switched to license plate recognition, data collection, parking enforcement for residential parking permits, and for meters for our pay-by-plate areas. And this tool originally we were using it just on the metered side, and then I was like, hey, we can do some interesting stuff with RPP with this now that we're using LPR for data collection. So as the PCOs drive around the city, we get the data, and it's automatically fed in, and it's up to date. This is just from a few days ago, and we're able to just kind of see what's going on. The advantage is you get this massive amount of data, and it's updated, so you can kind of see what's going on recent time. The harder thing with working with the PCO data in particular, this is not related to the tool, it's related more to what's going in. But with the PCO data, you're at the whim of whenever a PCO goes out to a certain neighborhood. And it's a little bit of a black box for us, to be honest, in terms of understanding why some blocks are covered every day, why some blocks never get covered, why some blocks are covered on a weekly basis. So you're sort of at those whims, and you also can't control for things like street cleaning with those as well. So the paper, as I said, easy to schedule. You could also capture hang tags, and those construction permits a lot easier. but it's harder to ensure this in consistent collection. It's also expensive, either money or time. Whereas with the PCO data, working with the Dixon LPR, Rapid LPR suite, easy to collect large amounts of data, consistent supply, and Dixon's been great in helping us compile and create new metrics and work with new metrics. But you may miss, because you're reliant on this PCO data, we're not getting as much feedback. All we're getting from them is how many cars are on the street, if they have permits. We're not getting the hang tags, we're not getting construction permits, anything like that. So that's a major consideration for us as well. So how do you deal with this messy data? And this has been a really interesting project for us, working specifically on our Hayes Valley evaluation and evaluating how pay or permit is working. The biggest thing is focusing on collecting the data well and collecting it consistently. With this Hayes Valley data, we have a before data set from 2019 and from 2020, and then we have an after data set from 2023, in addition to also folding in the data from Dixon. And we're dealing with all these different inventories, we're dealing with different times and different time periods between runs, and that's been really hard, especially for things beyond parking occupancy. If we want to look at turnover and we want to look at length of stay, it's been really hard for us to figure out exactly how to do this with the existing data that we have. So collecting data is really important, collecting that consistently. Being honest about data issues with the public, I think, is really important as well. I think we owe it to the public to be as straightforward about what issues and what things we needed to take out and put in. And I think it's hard because you don't want to fill something with footnotes or kind of leave something blank. But if that's what you feel like is the best way to approximate kind of what you're looking for in explaining to the public and getting that information out there, I think that's really, really important. I think being thorough and inquisitive in reviewing data has been really, really important as well. Dealing with all these different data sets coming across from all these different sources, there have been all sorts of inconsistencies that we've discovered, and Lulu, one of the planners on my team, keeps finding these little things where it's like the things are not passing the eye test, passing the smell test, and you have to dig in further to make sure things aren't being double counted. We have blocks where in some databases it's split in two by an alley, and in some databases it's not. And that takes a lot of time and a lot of effort to kind of work through and think through. It's not just about like taking looking at the data and taking it as is. It is about kind of sitting with it, playing around with it in Excel or whatever it is you use, and trying to investigate anything that seems off. I think it's also important to consider how each metric can fit a narrative. And it's often hard because you don't know what the metric is until you calculate it, but going through this planning process and data planning process and sitting down and saying, this is the kind of story we want to tell, and work backwards from there. And I think with parking occupancy, we were always going to collect that. One thing that I've been trying to get at, and we've been working through, and we're still kind of working through this, is with pay or permit, there is this kind of inherent contradiction that I wanted to be able to talk about with the public. It's this idea that when we're charging for visitors to park on the curb, the occupancy should go down. There should be more spaces available. But everything we know about parking meters also say that there should be more turnover and therefore more vehicles able to park. So I think the metric that we want to look at, and that I am still working with our data to hopefully be able to kind of get in a reliable way, is to be able to have both of those things, to be able to say to businesses near pay or permit blocks, to be able to say, not only are we making it easier for people to find a place to park by increasing availability, but we're also getting more people through the neighborhood. So getting that solid metric of 350 cars were able to park here instead of 304, I think is really important to us to be able to do and to be able to tell that story. But to get to that number, you need to make sure that you're collecting the data right. That's something that is upstream, and for the before data, it's the toothpaste is out of the tube, but you could sometimes find these comparable data sets or comparable parts of the city to talk about. And I think a lot of these numbers are confusing, but I think putting them in understandable contexts has been really helpful. And both in Hayes Valley and in other projects that we've done, you take this number and you have this big occupancy number, 80%, whatever it may be. It happened to be 80% when looking at all of our Dixon data, which is funny. But what does that mean? And I think being able to talk about how it changes over time, over the course of a day, or over a geography, I think is really helpful. This is a set of maps that I was really happy with for a project we did in the Excelsior neighborhood in San Francisco. And this is, taking this occupancy data, and we knew that the occupancy, the red is the highest occupancy, above 90%. A lot of these blocks were above 100%, above 110%, which is, it's always fun to have to explain why occupancy data can be above 100%, but that's where the illegal parking and double parking comes in, the way we measure it. But being able to show, even with, with all the caveats of the occupancy data, you're able to kind of keep it consistent. We had consistent data collection, and we were able to sort of show over the course of the day that you see a lot of red at the 5 a.m., especially in the kind of the eastern part of the map. As the day went on, at 10 a.m., the neighborhood's cleared out. The 2 p.m., cars start to filter back in, and by 8 p.m., it's almost as full as it was at 5 a.m. And this was a really important way to tell the story for this neighborhood of residential parking permit program that serves only during the day is not going to work in this neighborhood, and saying that just looking at this and looking at the timeline and really seeing that it's at 5 a.m. that the parking problem is the worst, we need to think a little bit outside of the box, outside of our own box when working with a neighborhood like this. So, and being able to show that and talk about it and contextualize it takes these, what otherwise would be kind of tables and kind of scattered all over the place, and really shows in living color what we're dealing with. The other thing is, and this comes back to the politics of it all, I think any sort of regulation, any regulation change is always going to be it's always going to be political. So we did, in addition to the occupancy data, I think it's also important to get survey data as well. So this is also from Excelsior project in 2019, which we did not end up doing residential parking permits in this area because of COVID, but we collected data about we sent out a survey to 1,800, it was received surveys from 1,800 residents in the area, and we were able to sort of map the hot spots of support for residential parking permits, and able to show that, like, near Mission Street, where there's a lot of businesses, that's where the highest demand for the permits are, and less demand for the permits the closer you get to the park. And that's a way to tell this story, and an important reminder, I think, going through the process. And you learn it very quickly in my role and in my work, where when you go up to the public and you're just talking about the data, you immediately will start to hear back the personal stories, the personal anecdotes, the personal opinions. I think this project was especially interesting because you'd get a lot of contradicting thoughts that you'd have to kind of work through. A lot of people who don't like circling for 45 minutes to find a place to park, but also who don't want to pay, at that time, I think $150 for an annual permit, or don't want to make their neighbors pay. And having that side of it is just just as important as a lot of this other data as we go through our work. So looking ahead, looking forward to the future, I think one thing that we're interested in is better data collection and management, and I think we're already starting to go in that direction. I think the Dixon Rapid LPR tool has been really eye-opening in terms of, being able to take large amounts of data and kind of and be able to work with it. Because previously everything was paper and manual. I do think that we have to think more about the collection side, though, because to be able to get some of the data we want, we need that consistency of collection, which we do not get with the PCO data. I think we are desperately in need of new metrics and new methods of storytelling. I think as I've been going through this process and been thinking about parking occupancy and thinking about how it's not a flawed metric in terms of understanding what is going on the street, and it's also a very easy to compute, easy to understand metric, which is easy to explain metric, which I think is really helpful, at least at that surface level. But as we saw, all sorts of questions, all sorts of issues with that. I think these could also lead to a lot more innovative policy proposals, and this gets back to what I was saying before, how most cities are running their RPP programs just on demand, just on interest from residents, and I think for a long time that was working, but I think as neighborhoods change and as cities change, we're getting into a place where these metrics, or where the policies are not working for folks the policies on the street are not working for everybody. And I think we're starting to really do a disservice to residents by kind of keeping this status quo. And I really do think that this will be a tension that'll start to really come to a head in San Francisco and Los Angeles and other places. I know there's a bill going through that at some point in the legislature. I don't know where it is right now, but a bill to make it so that to make it easier for LA to exclude new buildings from residential parking permit areas. And I think that is a whole extra conversation, another sub conversation of how do we welcome these new residents into the neighborhoods, and how do we deal with that while also dealing with changes in the amount of parking we're able to build. And I think the future, a lot of these political headwinds are always going to be the same. I think no matter what data you have, no matter what tools you'll come up with, you are still going to have to be doing a lot of the kind of retail politics and trust building that is so important to really anything in transportation planning, especially at the local government level. Building that trust with a neighborhood and with the community and with residents is always going to be important, always going to be a vital part of what we do. And I think building that, no matter what fancy data we come up with, I think that's always going to be really important. Talking about a specific thing in the future, which is very exciting, we've got our digital curb project coming up. In San Francisco, we received a grant from the DOT under their SMART grant program to digitize all curb supply and regulation in San Francisco. And we're one of the few cities looking through the SMART grant proposals. There's a lot of great work happening in curb management around the city, around the country. I'm sure a lot of you may be working on that as well. Similar to the issue I talked about at the top, though, a lot of this is focused in on loading, on high demand curbs, and on pilots in downtown areas, which very important, very intense. But I'm very happy that in San Francisco we made the decision to do the whole city, to get every little piece of curb. And I think the exciting advantage is, one, we're going to fix our regulation data set. We'll know by coordinating with the signs, we'll know, and the legislation will know exactly what the regulation is on every block in San Francisco with accuracy. We'll also know how many parking spaces there are, so no more approximately. After digital curb, we'll have that number. It'll be a hard number, and we'll also work with on the updating is also really important, keeping this data up. So I'll make sure that whenever we put in a bike lane, whenever we convert parking from parallel to perpendicular, whenever we make any other changes to parking supply, or anything like that, we will have that there, and then we'll be able to layer in occupancy data from, whether it be from the PCOs or whether it be things that we collect. We're able to layer in that occupancy data and make that all work. And this also will be in this new curb data specification format from the Open Mobility Foundation. I know that compilers involved, right, with OMF and a lot of other groups both in the public sector and the private sector. And this is something that I think was sorely needed, both by cities to understand their own data, but it's also something that Google and Lyft and Uber and all these other UPS, FedEx, all these other groups that use this data, they really want the curbs a mess. Every city keeps it in a different format, and we're at a place where transit was 10 or 15 years ago, not having, transit was in a similar situation, and then the GTFS came around, and still a work in progress, getting cities involved, but now Google can go tap into a solid format to show you your transit services, and that's going to be the future in curb as well. And Vicky mentioned in the LinkedIn post about Code the Curb. Don't know as much about the details there. I'm sure LA folks know a little bit more. Sounds like a similar process with open development effort to kind of map the curb, and I think this is all really exciting and really can change the way we do this data and can lead to some more things. I also wanted to sort of end on thinking about this reframing data, this point that I've been hammering home, and kind of bringing an example from transit. So transit, you could talk about the transit service in a lot of ways. You can start with the number of trains per hour, and that's the very operational way to think about it. Of we're sending out 6 trains per hour. You see this a lot, especially in the UK context. They like to talk about service that way, and it's definitely helpful operationally. But as a writer, you have to do sort of math to figure out what that necessarily means to you. So you could then move from that to saying, there's a train coming every 10 minutes. And that's a lot more helpful. You could kind of make that work and figure that out. But beyond that, there's this average wait time. And it's not exactly 5 minutes. There's a whole paper on this about how there's other factors, like platform length and dwell time, things like that. So you really can get to that number. And that's really the number that we care about. I don't really care how many trains are coming through the station unless I am sending the trains out. If I'm not running trains, I don't care. I don't care how many trains there are. I care about that last thing. I care about an average wait time. And I think parking, similar. We start off with this question of occupancy. 80% occupancy, that's helpful for me to understand, especially helpful for metering parking, because we know how much money we should be expecting to come in, and that's really important. But does that really tell the story? And so I've started, less so in this presentation, but I've started to sort of flip that around to availability. And I think that adds that urgency a little bit because it's such a low number in a lot of situations, but it also, I think, speaks a little bit more to what people are expecting to see and how people interact with the curb. But that doesn't necessarily tell the whole story, and I think there is this other factor, and there's a paper, I'm blanking on the author, so there is a paper that attempted to do some of this work with coming up with other metrics like search time and probability of finding a space, things like that. And I think those are very exciting. I think you need a lot of data, a lot more data than we have right now to be able to get to that. But I think once we get to that, it makes it so much easier to tell stories, so much easier to justify any of these sort of policy regulation changes that we feel that we know we need. And it can also help us identify areas that are really struggling from this and really help us, more importantly, as public servants, we're serving the public. And I think when we go in front of a body and say, or in front of a community group and say, oh, there's 90% availability or 90% occupancy, 10% availability, however you want to say it, they're going to come back at us with whatever their experience is. They're going to come back with us with, oh, it took me 45 minutes to find a place to park, or I come back to my block and most of the time I can't find a space or can't find a space in the whole neighborhood. So I think as we're thinking through data and as we have more than just what we get off of a clipboard and what we're putting into Excel on our fingertips, I think that's where I'd hope to see this future going in residential parking data. So that's all I have. Thank you, compiler. Thank you for everyone else with Data and Donuts for inviting. Thanks to our data partners as well, and our residential parking policy team, and the rest of the team at MTA. And I'll leave you with thinking about the public. I've always thought we needed a mascot. So this is Kirby, curb management mascot. It's an anthropomorphic curb grew out of the street and is here to tell you about curb management. So any design folks, if you want to take that and run with it, feel free. So thank you guys.